Hello everyone, welcome to Indian National Junior Science Olympiad 2018 Physics Solutions. A particle moves along positive x-axis with a velocity in suitable units varying as 4 minus 3t minus t square, where t is time in seconds. Students draw following four conclusions. Initially, the particle is at origin. Initial speed of the particle is 0. The particle decelerates till t equal to 1 second. The speed of the particle goes on increasing after t equal to 1 second. Velocity of the particle v equal to 4 minus 3t minus t square. Dx by dt equal to 4 minus 3t minus t square, from which dx equal to 4 minus 3t minus t square into dt. Upon integrating between limits x0 to x and 0 to t, we have the expression for x, that is displacement, as x0 plus 4t minus 3t square by 2 minus t cube by 3. Similarly, differentiating velocity expression with respect to time, we have acceleration as minus 3 minus 2t. Now let us see the statements one by one. Displacement of the particle x equal to x0 plus 4t minus 3t square by 2 minus t cube by 3. At t equal to 0, x equal to x0 or x equal to 0. Speed of the particle v equal to 4 minus 3t minus t square. At t equal to 0, v is 4 meter per second. Acceleration of the particle a equal to minus 3 minus 2t. At t equal to 0, a equal to minus 3. At t equal to 1, a equal to minus 5. The particle comes to rest at t equal to 0. V equal to 4 minus 3t minus t square, that is v is 0 at t equal to 1 second. Since the acceleration is negative, it will increase the speed of the particle after reversal of direction. So 1 is sometimes correct, 2 is never correct, 3 and 4 are always correct. A ray of light passes through a thick glass sheet with some angle of incidence theta as shown. The refractive index of the glass is. For normal incidence, mu equal to real depth by apparent depth, that is AC by DC, that is d by DC. Since the light ray is incident at an angle, there is some change in DC, so the refractive index is approximately equal to d by DC. You can study the ray diagram for better understanding. A beaker of mass 50 gram with 262 gram of water in it is kept on a weighing machine. A uniform hollow brass ball of total volume 36 pi cc is inserted into water in the beaker. It is observed that the ball floats on water. The weighing machine now reads 400 gram. Density of brass is 8 gram per cc, while that of the air in the ball can be neglected. Thickness of the brass used to prepare the ball must be nearest to. Initial reading of the weighing machine 262 plus 50, that is 312 gram. Final reading of the weighing machine is 400 gram. Of the brass sphere, so 400 minus 312, that is 88. Volume of the brass sphere is 4/3 pi r cube equal to 36 pi, from where we get r equal to 3 centimeter. Mass of the sphere m equal to volume into density, so it is m equal to 4/3 pi capital R cube minus small r cube into rho, from which we have small r equal to 2.89 centimeter. So the thickness of the brass sphere will be capital R minus small r, that is almost 1 mm. If a body exerts a force on a surface, the surface exerts a reaction force on the body. This reaction force is always along normal to the surface at that point and is popularly known as normal force N. When the body slides on the surface exerts a force of friction on the body in the direction opposite to the direction of slipping. The magnitude of this frictional force is given by mu n, where mu is a constant called the coefficient of friction. For a given pair of surfaces in contact, and n is a normal force. Consider a block of mass 100 kg placed on a level surface. If one person tries to push it with a force F, he is unable to do so. He receives help from two of his friends and each one applies the same force F. Now the block moves with uniform acceleration of 0.5 meter per second square. After some time, one of them happens to leave the exercise of pushing the block. This time the block moves with a uniform speed. The magnitude of force F and the coefficient of friction mu respectively are. When one person applies force F, the block remains stationary. When three people apply the force, the block accelerates. So F net equal to ma, 3F minus Fk equal to ma, from which we have 3F minus Fk equal to 50. When two people apply the force, the block moves with constant speed. So F net equal to ma, 2F minus Fk equal to m into 0, which gives us 2F equal to Fk. From the above equations, we get F equal to 50 Newton. Put this value in the second equation, we have 2F equal to Fk, that is 2 into 50 equal to mu k into n, which gives us the coefficient of friction to be 0.1. Some people face problems seeing distant objects clearly. They, however, have no problem seeing nearby objects. A person wears a spectacle with concave lenses to see distant objects. He is able to see nearby objects clearly without using lenses. When this person is reading without using spectacles, the image will be formed on the blind spot, behind the retina, in front of the retina, in the fovea region of the retina. A person suffering from myopia, that is short sight, is not able to see distant objects because the light rays coming from the distant object converge at a point in front of the retina. So the correct option is C. A magnet is in the form of a bar. Initially, the axis of the bar magnet is along x-axis. At some distance from the magnet, a coil is kept in YZ plane with its center along x-axis. Which of the following motions of the bar magnet will not induce electric current in the coil? A translational vibration perpendicular to x-axis. The bar magnet axis is turned to make an acute angle with the x-axis, and the magnet is rotated about x-axis with the south pole fixed on the x-axis. The bar magnet axis is swinging back and forth about the x-axis with the south pole fixed on the x-axis. The bar magnet spins about a perpendicular bisector as its axis of rotation with its center of the x-axis. As seen from the diagrammatic representations, we can see the EMF is induced only when there is change in flux, and the change in flux is not taking place in option 2. A falcon and its trainer are exactly midway between two vertical and parallel hills. As the trainer fires the gun, the falcon starts flying directly towards one of the hills. The falcon hears the first and second echoes of the gunshot at 2 and 3 seconds respectively. Ignore reflection of sound from the falcon and from the trainer. The air is practically still. Among the following options, respective speeds of the falcon and the sound in meter per second could be. Let V and Vs be the speed of falcon and sound. Distance travelled by the falcon at the first echo is 2V. Distance travelled by the sound at first echo is d by 2 plus d by 2 minus 2V, that is 2Vs, which implies d minus 2V equal to 2Vs. Distance travelled by the falcon at the second echo is 3V. Distance travelled by sound at the second echo is d by 2 plus d by 2 plus 3V, that is equal to 3 times Vs. That implies d plus 3V equal to 3Vs. From the two equations we have Vs equal to 5V, that is speed of sound is 5 times speed of falcon, which is correct in option B. At a time t equal to 0, an object is dropped from point A that rebounds inelastically, losing some of its kinetic energy with a speed of 10 meter per second after making a collision with the ground. It finally attains the maximum possible height at t equal to 4 seconds. What is the difference of height at t equal to 0 seconds and t equal to 4 seconds? Ignore air resistance as well as time of impact. Let the object be dropped from a height h. Speed of the particle after collision is 10 meter per second. Time taken to attain maximum height v equal to u minus gt, that is 0 equal to 10 minus 10t, which comes out to be 1 second. So the time taken for free fall is 3 seconds. Maximum height reached by the object h equal to u square by 2g, which comes out to be 5 meter. Height of free fall h equal to half gt square, which is 45 meter. So the difference between the heights is 40 meter. 5 polyester balls labeled P, Q, R, S and T are suspended from insulating threads. Several experiments are performed on the balls and the following observations are made. Ball P repels R and attracts Q. Ball S attracts Q and has no effect on T. A negatively charged rod attracts both P and T. Which of the following options correctly describes the nature of charges on the respective balls? 0 refers uncharged. Let us see the observations one by one. P repels R and attracts Q. So, if P is plus or minus, then R is plus or minus and Q is minus or plus. Ball S attracts Q and has no effect on T. So, S is 0 and T is 0. A negatively charged rod attracts both P and T. So P is positive and T is neutral, because a neutral object can be attracted by either a positive charge or a negative charge because of induction. Two identical circular rings are placed in a plane in such a way that they pass through each other's centers C1 and C2 as shown in figure. Resistance of the wire forming each ring is 36 ohm. Conducting joints are made at the intersection points A and B of the rings. An ideal cell of EMF 2 volt is connected across A and B. The power delivered by the cell will be. For the given arrangement, 1/3 of the ring lies inside the other ring. So the circuit can be redrawn as follows. Effective resistance of the circuit is 4 ohm. Current through the circuit is 0.5 ampere. So the power delivered by the battery P equal to V into I, that is 2 into 0.5, that is 1 watt. In the circuit shown below, the internal resistance of the battery is 1.5 ohm and its EMF is 20 volt. A multimeter in its voltage mode is connected between P and Q. Internal resistance of the multimeter can be taken to be infinity. The multimeter reading is. The circuit can be redrawn as follows. Effective resistance R equal to 2.5 plus 1.5, that is 4 ohm. Current in the circuit I equal to V by R, that is 5 ampere. As the resistances of both branches is the same, current divides equally in them, that is 2.5 ampere. We can apply KVL here. VA minus VP equal to 2.5 into 3, that is 7.5 volt. VA minus VQ equal to 2.5 into 2, that is 5 volt. From both the equations, we have VQ minus VP equal to 2.5 volts. So the voltmeter reading is minus 2.5 volt. A point object is moved away from 5 cm to 90 cm along the principal axis of a concave mirror of radius of curvature 60 cm. Distances are from center of the mirror. Using Cartesian sign convention, calculate the image distance V for at least 10 suitable object distances U and tabulate the values. Plot a graph of V against U using the tabulated values with proper choice of scales. Radius of curvature 60 cm, so the focal length is 30 cm. Applying mirror formula 1 by V plus 1 by equal to 1 by F. When the object is within the focal point, U is less than 30, image is formed behind the mirror. When the object is beyond focal point, U is greater than 30, image is formed in front of the mirror. When the object is at focal point, U is 30, image is formed at infinity. You can see different values of V corresponding to different values of U tabulated below. You can see the UV graph drawn in the 4th quadrant. Pause the video for some time and go through the graph carefully. A stable carbon nucleus has 6 protons and 6 neutrons and a radius of 2.7 into 10 power minus 15 meter. The 6 protons repel each other so that each proton experiences equal resultant force from the other, which is also the minimum resultant repulsive force. For the purpose of calculation, assume that the protons and neutrons are point particles and protons are point charges. Also assume that protons and neutrons get distributed inside or on the surface of the sphere of radius given above. The nuclear force which gives nucleus its stability is not discussed in this question. Draw a simple sketch or explain in few words the orientation of protons in the nucleus when the above mentioned condition is satisfied. Here you can see all the 6 protons distribute themselves on the surface of the sphere at given positions 1, 2, 3, 4, 5 and 6. Obtain the expression for the resultant repulsive force on one proton due to remaining protons. Let's calculate resultant force on proton 1 F1 bar equal to F31 bar plus F241 bar plus F561 bar. Kq square by 4r square plus root 2 times kq square by 2r square plus root 2 times kq square by 2r square, which simplifies to kq square by 2r square of 2 root 2 plus 1 by 2. Calculate the magnitude of this repulsive force. Substitute the numerical values corresponding to charge and distance. We have the magnitude of force to be 52.6 Newton. Calculate the attractive gravitational force on this proton due to the remaining protons under the conditions stated above. So F1 bar equal to F31 bar plus F241 bar plus F561 bar, that is gm square by 4r square root 2 times gm square by 2r square plus root 2 times gm square by 2r square, which simplifies to gm square by 2r square times 2 root 2 plus 1 by 2. By substituting the masses and capital G value, we get it to be 4.8 into 10 power minus 35 Newton. Calculate the approximate ratio of repulsive electrostatic force to attractive gravitational force. Since we have the magnitudes of both forces already calculated, we can take the ratio as 52.6 by 4.8 into 10 power minus 35, which comes out to be approximately 11 into 10 power 35. What is the direction of resultant electrostatic repulsive force on this proton? As seen from the diagram, the resultant force acts vertically upward. A tank measuring 3 meter length, 3 meter breadth and 2 meter height contains water to 80% of its capacity. The tank is moving with a uniform velocity along a smooth horizontal surface. Will the surface of water be horizontal? If not, sketch the nature of the free surface. From t equal to 5 seconds, the tank is accelerated along its length at a meter per second square. Will the free surface of water be horizontal? If not, sketch the nature of the free surface. Determine the maximum value of acceleration A such that water does not spill over the tank. Complete the following statement by choosing the correct options. During accelerated motion of the water tank, an air bubble trapped inside will move parallel to the direction of acceleration A in a direction opposite to the direction of A, vertically upward in a direction perpendicular to the free surface of water. Let us see the answers in the next. When the tank moves with uniform velocity, the surface of the liquid remains horizontal. When the tank accelerates in horizontal direction, the surface of the liquid will be as shown in figure. For maximum possible acceleration, tan theta equal to a by g, from where a equal to g tan theta, that is 2.67 meter per second square. During accelerated motion of the water tank, an air bubble trapped inside will move in a direction perpendicular to the free surface of water as shown in the diagram. The electrostatic potential difference Vb minus Va between 2 points A and B corresponding to electrostatic force is defined as the change in electrostatic potential energy per unit charge as it moves from A to B. A charged particle of mass 0.02 kg moves under electrostatic forces only from A to B, having a potential difference of 10 volt as shown. Velocity of the particle at A is 20 meter per second and at B is 40 meter per second, and their directions are perpendicular. Calculate the charge Q on the particle. Applying work energy theorem, W naught equal to delta K. VAB into Q equal to half m into VB square minus VA square. Substituting the given values, we get Q equal to 1.2 Coulomb. Two helicopters X and Y are stationary at a distance of 80 meter from each other and 10 meter above surface of sea near the Antarctic. The two helicopters have sound detectors. Helicopter X is stationary vertically above a 50 meter thick block of ice. For the purpose of calculation, the vertical section of the block can be considered to be rectangle. A blue whale W is stationary vertically below X and 50 meter below the water surface in such a way that there is no ice in the line of sight between the whale and the helicopter Y. This line of sight intersects water surface at point M. Whale W gives out a call which is detected by X. Y received the same sound 0.07 seconds after X received it. For practical purpose, helicopters are considered to be point objects. How much height of ice is floating above the surface of sea? What is the distance Ym and Yw? What is the time taken for sound to travel from W2 to Y after W makes the sound? What is the time taken for the sound to travel from W to X? What is the velocity of sound in ice? Let us see the answers in the next frame. See the diagram carefully for some time. Applying laws of flotation, gravitational force equal to buoyancy force, mg equal to m dash g, that is V into rho of ice equal to V in into rho W, which gives us height to be 45.5 meter. So the height of ice block above water is 4.5 meter. From the diagram, yw square equal to xy square plus xw square, which gives us yw equal to root of 80 square plus 60 square, which is 100 meter. From similar triangles wxy and bxy, we can write 80 by bm equal to 60 by 50, which gives us bm equal to 200 by 3 meter. From the triangle BWM, MW equal to root of 50 square plus 200 by 3 whole square, which is 83.3 meter. So YM equal to 16.7 meter. Time taken by sound to travel from W to Y, TWY equal to Wm by V liquid plus My by V air, which is 83.3 by 1500 plus 16.7 by 350, which is 0.103 seconds. Given time Wy equal to 0.07 plus time Wx, from there time Wx equal to time Wy minus 0.07, that is 0.033 seconds. Velocity of sound in ice Twx equal to 4.5 by 1500 plus 50 by velocity of sound in ice plus 5.5 by 350, that is 0.033. Upon simplification, we have velocity of sound in ice to be approximately 3496 meter per second.